I sat down to check the trajectory of UTME physics problems for the past 5 years, and I realized something. I discovered that semiconductor is now a very important topic in UTME physics. At least you are going to get 8 to 10 questions in semiconductor physics in your UTME for 2026. Let's look at this question. Addition of trivalent impurity to a semiconductor dash. You cannot solve this problem if you don't understand what all of this is all about. Semiconductor is a material that has its conductivity and resistivity in between that of a conductor and an insulator. And we have two major types. It can be the intrinsic semiconductor, also called the pure semiconductor, the popular guy is silicon, germanium. And we have the extrinsic semiconductor, also called the impure semiconductor. Now, let's go back to the problem. Addition of trivalent impurity. That means that we can actually add impurity to semiconductor. And that is where we have what we call the extrinsic semiconductor, the impure guys, which are obtained by adding small amount of impurity to a pure semiconductor. That process on its own is called doping. But that is not the problem here. Now, we added trivalent impurity to a semiconductor. That means that we can add some other kind of impurity. Yes, there are two major types of impurities that can be added to a semiconductor to make it impure. We have the trivalent atoms and we have the pentavalent atoms. What will the trivalent atom do? Now, let's go back again to semiconductors. Semiconductors generally possess two charge carriers. There are two things in semiconductors that enable current to be conducted. And those things are the free electrons and the holes. So when we add trivalent atoms or trivalent impurities, which are also called acceptor atoms, to a pure semiconductor, when we have a pure semiconductor, we have equal number of holes and free electrons. But immediately we add an impurity, it's either we have more holes or more free electrons. When we add trivalent, what are the trivalent guys? The bag-it guys. This can be a question on its own. The bag-it guys are the trivalent guys. Boron, aluminium, gallium, indium, and thallium. The bag-it guys. If you add any of these to a pure semiconductor, what will happen is that the number of holes will increase. And that is the solution to this problem. If you want to know what will happen when we add a pentavalent atom instead, what will happen to the semiconductor, just follow me in the next one and you are going to see it. My name is Green.